Hello students! Today we're going to be talking about Stanovich Chapter 4. So this chapter focuses a lot on qualitative data collection, and so we're building on some of the things that we've discussed in the past of theory and testing theory, and also testing hypotheses, and we're going to talk about how qualitative data fits into that. So let's get into it. Some of this is review right here, but I just wanted to remind you that science is how we do the process of figuring things out. So we use theory to come up with hypotheses. Our theories suggest things that should happen, things that we should be able to observe. So we use theories to create a plausible hypothesis, and then any individual study is testing a hypothesis. You can also be doing a descriptive study where you're not testing a hypothesis, but usually a study is going to be testing some hypothesis, testing for some relationships, looking for some connection that this theory suggests might be there. So generally you are only falsifying that one hypothesis with any given study. A study might have 3 hypotheses or 4 hypotheses, but generally you're just falsifying hypotheses. And as we've talked about before, the more and more times that the theory's predictions come out to be the case, then we can be more sure that the theory is accurate, but we could falsify all our hypotheses and not affect the overarching theory. So with that, multiple studies are needed to support or falsify the bigger theory, but any given study, you would falsify your hypotheses within that study. So for example, in a recent study, I had hypothesized that there would be no correlation between 2 variables. I was thinking that my scale of heroism would not assess this specific aspect of self-efficacy. I didn't think that they'd be correlated, that heroes wouldn't be higher or lower on self-efficacy. That turned out not to be the case. There was actually a relationship between those, so my hypothesis, my original hypothesis, was falsified. I was incorrect there. But that single hypothesis was falsified. It didn't mean that the overarching theory that we have about the development of heroes was falsified. So with this, one of the things with unfalsifiable theories we've talked about before is that often you're revising or rethinking your explanations of the theory after the fact. So we used Freud as an example. That is not a useful theory. So it's not a scientific theory. Scientific theory needs to be that big, broad explanation of the observations we've made in the past and can explain future predictions of things that you might see. So with this, oftentimes testimonials are used in support of an unfalsifiable theory. You say, well, this specific example, this specific person had this specific experience, and that is supportive of this theory. So testimonials are often used in that way to support some kind of unscientific theory. And so when you do this, when you're using testimonials to support something that's unscientific or unfalsifiable, we as scientists can waste a lot of time and money and use inadequate care. So with that, we don't want to be propping up and supporting these theories that are not scientific. So that's why I want to talk today especially about how we can use things like qualitative data, a testimonial, in an appropriate way. So whether it's a case study of one single individual, or whether it is one person's experience within a group or something like that, there are ways that we can use individual experience as useful data. But the ways that we'll talk about in using testimonials are often used in ways that does not support scientific theories. So one thing with this is the concept of vividness. So vividness as we're making decisions, the facts that are most personally relevant to us usually are the ones that we focus on. So our relationship experiences, like our own personal experience, will probably matter more to our decisions, whether to date or not date this person or something like that, compared to what our friends advise us. Right? So our own personal vivid experiences and memories are probably going to be more relevant. So things that are more personally relevant to us in decision making, maybe even for something like getting a new TV. Well, what's the most important for me? It might be something that's not as important for my partner or something like that. Or getting a new car for your family. So maybe you want something that's faster, but that might not be the best decision, right? So whatever's most personally important to you or personally relevant, what's most vivid in your mind, tends to be how we make decisions. So with this, in human decision making, I'm going the wrong way here. Sorry. So with that, we have a problem where we sometimes ignore facts in front of us for things that are more vivid to us, that are more personally relevant. And so depending on what the decision is, that could be a good way to do it, to go based on what's more vivid, what's most important to me. Or if we're talking about science, we want to look at the actual current facts in front of us. So even though it might be more personally relevant, like this one aspect of the study, and ignore this aspect of the study, we as scientists need to recognize that this can be a human decision-making problem. We might unwittingly kind of ignore some of the features or some of the things that we're finding and not focus on that. Focus on the things that are most vivid to us. So with this, we'll often use information from memory that we perceive to be useful to the situation in decision making of something to buy in the store or what kind of car to buy. And we can fall into a trap of just basing our decision on the most vivid information. So if we see a plane crash as more dangerous than a car accident, for example, we might be less likely to fly in a plane. Like, we might have a fear of flying, but car accidents are much more likely to happen than a plane crash. So air travel is much safer than car travel statistically. So if we see those big dramatic examples of plane crashes, that might be more vivid to us and change our decision-making processes. Oftentimes parents have a fear of abduction of their children, but it's actually a fairly low risk, or statistically speaking, it's a fairly low possibility. So it's actually a higher risk to get in a car accident on the ride over to school, like commuting to school in the morning. So with this, the risk for my recent surgery I went to was less than a risk for the car ride to get there. So as the person attending me was talking about and having me sign paperwork and whatnot, like, these are the risks, the potential risks of this surgery, like going through things like infections and things like that. And there's like this, I forget exactly what percent, but like a really low percent probability or risk of death during the surgery. And so they qualified that and said, just so you know, that's a much lower risk than the statistical risk of you driving here to the surgery today. So they did this because it tends to be a problem with people having that as a vivid thing. Oh, I'm going to surgery. Surgeries can have really bad complications, even though for some surgeries, those kind of complications are super, super rare. But it's vivid in people's minds, and so they had to adjust how they were speaking to the patient because people tend to make decisions based on what's most vivid to them. So, and we might unfortunately do this as scientists, looking at our results or ignoring some results inadvertently. So a placebo is also important here. A placebo is an example of a fake treatment that mentally creates a positive outcome, regardless of if the treatment actually does anything beneficial. So you can think of placebo like a sugar pill. So we can use placebos in ways other than just a sugar pill. So comparative groups that have another kind of treatment that's not actually the real treatment, for example, could possibly have a placebo effect. So any attempt of treatment has been reported to make people feel better. So any kind of illness or disease, people getting treated like a group of people overall that get a treatment, even if half of them get a placebo, even those people getting a placebo tend to report feeling a little better. So that's what we're talking about with placebo effects. Control groups often get a placebo in experiments, and studies sometimes need to account for placebo effects. There's been enough studies on placebos in medicine, for example, that for different kinds of medicine, there are statistically known quantities of about how often placebo effects happen. So placebo effects can account for about 27 to 30% or 36% of people who claim a drug therapy gave them relief. So that's a really high percentage. They're getting a sugar pill, and 27 to 36% of people claim that it gave them relief. So when doing the statistical analysis of these things and actually making sure, you need to account for that. Realize that that there are a portion of that population who just had this drug that had a placebo effect. And there's a variety of ways. We won't go into a ton of detail on the specific ways to take that out of the statistics, but it is possible. So Stanovich has a good summary of this. In short, placebo effects are potentially occurring whenever a therapeutic intervention is undertaken, so regardless of the efficacy of the intervention. So this also means, let's say there's two treatments. There's your new treatment for some disorder and the treatment that already exists that everybody already knows works. So maybe it works for, your new treatment works better for 10% of the people. Are those 10%? Is that a placebo effect for those people? You have to consider that as you're looking at the evidence. Obviously, if you created this new method, you'll want it to work, right? So that has to go into your scientific decision making, realizing whenever any kind of therapeutic intervention is done, it'll work for some people, or they will feel like it's working in some way. So that's why additional kind of measures to actually assess and make sure that you're getting valid data are important. So some studies intentionally show that the actual treatment works better than a placebo. That's one really obvious and good way to do this, is you show a placebo effect and you have a group with, say, no treatment at all, some that are getting the placebo, some that are getting the actual treatment, and can show that yes, your actual treatment, your actual therapeutic intervention is having a higher benefit. So that's one thing that a lot of studies have to do. So jumping back to testimonials, I mentioned these a minute ago. So testimonial is something kind of like what you might see in an advertisement, you might see in a review of a product, someone talking about the results were great, the vacuum was fantastic, this treatment was the best thing I've ever done. You've probably seen some kind of advertisements like that. But for our use as scientists, testimonies are virtually worthless as evidence for or evaluations of theories, hypotheses, therapies. They're pretty useless all in and of themselves, because any single individual may have very different expectations for what they're expecting going into the therapy. Or let's take the vacuum example. Maybe a person is just expecting that the vacuum will pull some things up out of a carpet but not work on hardwood floors, versus some other person might really want that vacuum to work on hardwood floors. So both these people get the vacuum. If the one is very happy with how it's performing, the other one is not, because it's not performing in the context that they want it to perform in. So every individual has different expectations, different experiences, different assessments of, is this really good, is this 5 stars, is this 0 stars, compared to any other. So using just a single testimonial can be a really useless way to get actual data. This being said, there are examples of case studies where you are studying the case of one specific individual. And we'll talk about case studies in a little more detail, but a case is like some kind of bounded system. So a case study of someone with a very unique illness, knowing their experience of how they're feeling through this illness or what their symptoms are. Even though that's still a case, we're studying it in a different way. We're using that data in a different way. It's not quite the same as a testimonial. So we need to use the data from individuals well to actually be good data and valid data for testing of hypotheses, theories, evaluating therapies, those kinds of things. So many times you'll see experts come onto a talk show or have a book on the shelf with a testimonial from someone, or use their clinical experience or talk about this case study to support their claims. And if you see that these are testimonials from individuals who have undergone the therapies and say that they're cured or that that's worked great, take it with a grain of salt. That's not how we as scientists should be using this data, and you'll see this a lot of times in advertisements. And the reason it's used in advertisements is because these stories are really easy to connect to. Our brains do a really good job at connecting to meaningful stories. They make a lot of sense, a lot more sense than, say, looking at this chart of data saying people who didn't get the treatment are way down here, people who got the placebo are here, people who got the actual treatment were over here. So having a story makes a lot more sense to our human brains, which are really good at getting the meaning from stories. But with that being said, as scientists, we need to be careful how we're using those individual points of data. So with that being said, testimonials can open the door to pseudoscience. We talked extensively about pseudoscience in chapters 1 and 12 of this book, even though the way I have the class structured right now, that's quite a few weeks ago at the beginning of the course. So pseudoscience leads to a lot of opportunity costs. If people see these testimonials and throw funding behind this treatment that doesn't actually have good evidence, we might end up spending a lot of time and a lot of money on these things that don't actually work. So there's a lot of lost opportunity for potentially actually useful treatments. So with this, pseudoscience can have direct harm as well. It's not just a silly thing that we can kind of ignore. There can be harm done. A really good example, well, a really awful example of this is the pseudoscientific claim that autism is connected to vaccination of children. So this is patently false, plenty of evidence for it, but the individual testimonials can be really convincing. But with that, it costs a lot of money and energy to do things like debunk those. It costs a lot of pain and trauma for families experiencing that or believing that or arguing about it. So pseudoscience can have really direct harm. So we need to be careful how we use this data from individuals. And that's what a lot of today's discussion is going to be about, how we can use this kind of story data, this kind of qualitative data in an appropriate way so we get good, valid information from it. So with that being said, I do want to point out that anecdotes can be really useful. These kinds of stories can be really useful. Like I said, human brains do a pretty good job connecting to stories, connecting to some kind of narrative or themes and things like that. So in explaining results, anecdotes can have a really useful place. So anecdotes are very useful, and we'll come back to this after this short video. Anecdotes are very useful, and stories and testimonials are actually very useful for convincing politicians to take up certain causes. So we'll talk a little bit about this more after we watch part of this video in all together.
Numbers are hard for us to conceptualize. Like, imagine a chair. Okay, now imagine 10 chairs. Easy peasy, right? What about 100 chairs? That's probably still doable. Now imagine 1,000,000 chairs, or 1,000,000,000, or 1,000,000,000,000 chairs. Chances are those...
So really quickly, maybe draw this out on a sheet of paper. Obviously, I don't want you to draw an actual trillion chair, but maybe draw a circle that you think represents the difference between 100 chairs, 1,000,000 chairs, 1,000,000,000 chairs, and 1,000,000,000,000 chairs. Maybe use a couple pieces of paper, but try to draw some circles about your conceptualization of these kinds of numbers. So pause the video right now, do that little drawing, and then we'll come back and see a better visual example of what these actually look like.
3 images, the 1,000,000 chairs, the 1,000,000,000 chairs, and the 1,000,000,000,000 chairs, in your head aren't actually all that different from one another. I mean, it's a shit ton of chairs, but how much bigger is 1,000,000,000,000 than 1,000,000 anyway? To our brains, they're not all that different. Theoretically, abstract.
So, look at your pictures. Hopefully you did draw some things. Look at your pictures. How different are those circles? From 1,000,000, from, what did I say first? 100 to 1,000,000 to 1,000,000,000 to 1,000,000,000. How different are your circles? How different is that conceptualization in your head? Because obviously, quantitatively, that's a very big difference. So here is a picture to scale. This is an example of what $1 million would look like, $100 million, $1 billion, and $1 trillion. So that is a to scale with a human there model of what these numbers actually mean. But our brains have a hard time doing that.
How much bigger is a trillion than a million anyway? To our brains, they're not all that different. Theoretically, abstractly, you understand the math, but the full weight, the reality of the sheer number of chairs, isn't something that the human brain is capable of grasping. As Joseph Stalin is quoted as saying, "If only one man dies of hunger, that's a tragedy. If millions die, that's only statistics." So because we have a hard time conceptualizing data like this, it's hard for that data to actually do anything in there. It's hard for it to stick. And if you want to change someone's mind, whatever you say needs to stick. This is especially the case when it comes to data that conflicts with someone's worldview or their values. These values often become literal.
So this is a good point, and we'll get to that, but I want to go back to the example that was just given. It's a lot easier to maybe conceptualize the experience of one individual maybe starving to death and a story about that, and it's more easy to grasp versus hearing like 100 people. Actually, I'm going to look it up really quickly. I'm going to pause my video. All right, so I just looked up a relevant statistic here, another example. So there is an estimate that based on the total numbers of people who are unhoused dying any given day, that it is about 21 people every day die because of the problems with being unhoused. So not adequate shelter, not adequate heat, not adequate food, these kinds of things. So that's harder to conceptualize when you think of over the course of an entire year. So this vast number versus the number of 21 people, that's a little easier to understand a day, but that's still a pretty big number. So understanding the story of one individual and their experience and what led to that, those kinds of things are a lot easier for our brain to do. So these kinds of stories can be really useful as we are sharing our data and our findings, but it's very important to use them appropriately rather than as data themselves as ways to explain some of our findings.
Stick. And if you want to change someone's mind, whatever you say needs to stick. This is especially the case when it comes to data that conflicts with someone's worldview or their values. These values often become literally hardwired in your brain's chemistry, and according to psycholinguist and my hero, George Lakoff, in most cases, the neural wiring and your identity stay, and the facts are ignored, dismissed, ridiculed, or attacked. It takes extraordinary openness, training, and awareness of this phenomenon to pay crucial attention to the vast number of facts we are presented with each day. In other words, it's not impossible for facts to change our minds, but it's pretty dang hard. So what else is there?
So this is one thing that goes to this point. As a researcher, realizing that this is the case, that oftentimes it's hard for us to even accept data that goes against our hypotheses. We need to do our best, one, to be open to understanding what that data actually means, not fall into this vividness problem we've been talking about, and then use examples, as we'll talk about qualitative data examples, in an appropriate way to show that there is support or not support for a theory or a hypothesis.
What can our brains connect with? What does have the power to change our minds? Well, stories. Stories and metaphors and anecdotes. Now that last one, anecdotes, is kind of a touchy word. If you've ever witnessed an argument on Twitter or Facebook or Reddit, you know the drill. The moment that someone brings in any amount of their personal experiences, the other person immediately shuts them down for using anecdotal evidence. Anecdotes, and stories in general, have a bad reputation when it comes to discourse. To use an anecdote myself, in my classroom, whenever we discuss research, I constantly have students talk about how good research doesn't have any personal experience in it. It's all data and numbers and hard facts. It's impersonal, aloof, inhuman even. And it's true that personal experience isn't a replacement for hard science and facts and data, but it is the language of our brains. Stories, feelings, are the best way to actually connect with someone. As an English teacher, I am telling you, if you are writing something argumentative, use feelings. That is how you really connect with an audience. Because we have minds made for stories.
So as a class on science and the profession of psychology as a science, this is an important thing to realize and remember, that as we are sharing things, yes, anecdotes, stories, metaphors, things like that are really good ways to help connect and help explain things, especially complex concepts. But we need to use them appropriately in that way and not as a testimonial supporting some kind of unscientific, unfalsifiable theory. Right? We can use this data in appropriate ways, and that's what this chapter on qualitative data is about. But there's a couple other good examples of things here that you might not have realized were anecdotes or metaphors of things that you've already learned that you might consider to be like really hard fact kind of based things.
Everything we do, every time we explain something, we explain using stories. Think about the news. No matter what happens, there's a plot of some kind. Somebody did something and got some result. There's intrigue there. This is even the case in science. When we explain a scientific concept to someone, we give life and agency to things that don't usually have it. Certain molecules are hydrophobic, which means they don't like water. Molecules can't actually fear anything. They don't care. It's chemistry. But we understand it through story. John won his battle with cancer. It's not a battle. Cancer cells aren't literally battling with the healthy ones. There aren't like little microscopic armies. That's not how it works. Law is also like this. Lawyers, prosecutors, and defense are telling two different versions of a story. One where the defendant did it, and the other one where they didn't. And sure, they use hard evidence to help them tell their stories, but at the end of the day, the jury's decision comes down to which side had the better, more believable story. And this is the case even for the subject that's maybe the furthest from storytelling, math. Now, you might be thinking that I'm going to be bringing up word problems where, like, Jose and Cindy need to figure out how many feet of streamers they need for their party, and then they have to convert that into yards when they go to the party supply store, and how all of this would be 1,000 times easier if we just converted to the metric system. And, I mean, yeah, that last part is true, but I'm actually...
So I'll put in a plug for the metric system here too, especially as someone with Japanese motorcycles and Japanese cars that all use metric system measurements in all the documents for maintenance on them. It's a lot better. It's a lot better of a system. It makes much more sense.
I'm not talking about word problems. I'm talking about just math, just the normal way that we talk about math, because it is full of metaphor. To once again quote my fave George Lakoff, if any area has been taken to be literal, disembodied, and objective, it's mathematics. Yet mathematics, too, is metaphorical through and through. Take the number line. Numbers don't have to be points on a line. It's a metaphor that numbers are points on a line. Mathematics turns out not to be a disembodied, literal, objective feature of the universe, but rather an embodied, largely metaphorical, stable intellectual edifice constructed by human beings with human brains living in our physical world. We use metaphors to help make things visible to our brains. Our brains have a hard time conceptualizing abstract things like the trillion chairs, and metaphors make those abstractions concrete. And then stories help to contextualize those metaphors. We want winners and losers. We want good guys who we can root for. We want tension and action and redemption arcs. Think about mythology. Myths are just how groups of people thousands of years ago conceptualized nature and disasters and seasons and pain and relationships and all of the other unexplainable phenomena around them. They understood the world through stories. These things, these stories, these metaphors, these concrete images are what affect us, not numbers.
Alright, so the point of this entire video, that's all we're going to watch from it. The point of the entire video is that facts and feelings work together in a variety of ways when you're intentionally trying to, say, change someone's mind and, say, some kind of debate or political ideology, those kinds of things. So that's more of the focus, and using stories to help do that. For our purposes, I think those examples given in that video are really fantastic examples of math is metaphor. We use these kinds of stories to connect. Our brains do this really well, make these kinds of connections. So the connections of a story of one individual's experience can be a really good, really illustrative way that we can connect with something a lot better than saying this number of people perish from homelessness every day, or there are 1 trillion chairs, or it costs $1 trillion to do X, Y, or Z. It's hard to conceptualize that. So look back to that picture that hopefully you drew, the difference between, say, 1,000,000, 1,billion, 1 trillion, and 100. There's probably not too much difference between those. Our brains have a hard time just using that kind of hard facts and data, even though some of that is also metaphor, the sizes of things, or giving it analogies. So this is how we as scientists can use and deliver our information. But we need to know how to use that kind of data of stories from people, individuals, groups, in a way to show support or not support for hypotheses and then theories largely. So one really interesting thing that policy evaluators have found is that it's really tough to get politicians to do anything unless you have lots and lots of money. But barring that, let's say you just want to actually convince them, like really convince them to do something, to actually be invested, to be on board, to want to make some change in some way. A really good way to do that, one of the best actually, to really convince them to do something, is to have really clear case studies. So, for example, let's say you are wanting to get more funding for this after-school program. One thing that has been really effective is you bring in maybe 3 kids who went through that after-school program and tell the politician, like in a meeting or something like that, exactly how good it was for them in their lives, their own story. So like 1 or 2 or 3 stories to really connect with, so that the politician can see and hear that and be like, oh, this, I will be on board with doing this. So these kinds of anecdotes, these kind of metaphors, these kind of stories can be very helpful to get information across, to get things done, and it's relevant in science, but we also need to know that those 3 individuals we need to be able to understand as a scientist, are those everybody's experience? Is it pretty uniform across the group, or is it actually harmful for some people? Is it not really as effective for most as it was for those 3? So we need to use this story data, this qualitative data, carefully to be able to understand for our hypothesis testing, for our descriptive statistic, or for our descriptive studies. So how do we do this? How do we use case study? How do we use qualitative samples of 3 people? How do we use that correctly? So let's make sure we have some clarification on some of these definitions. Quantitative versus qualitative. Quantitative is some kind of quantity. You turn observations into numbers. So, for example, I could say most of the class raised their hand yesterday during class. Or I could say 10 people raised their hand during class. So quantitative is 10. I put it to a number. I observed the behaviors and I gave it some kind of number. The measurement tool for purpose I've described in the class, that turns a person's level or feeling of do they have a sense of purpose in their life, it turns it into a quantitative number. In between, they get an average score in between 1 and 7. Qualitative, on the other hand, we often think of it as broader quality data. Kind of, in some cases, you're recording literally everything. So you're getting a ton of quality information. In the example of the raising hands, you might say, well, when people were raising, the people who were raising their hands, they looked interested, they looked excited. So you're getting more information. You're getting a broader quality of data, but you might not be turning it into numbers. Spoiler alert, most researchers use both of these, so kind of mix them together in different ways, so you can get the quality data of asking people what their experience was like in the class, but also get some quantitative data at the same time. So a lot of researchers do that. So with this, How many times did adolescents talk about their relationships? So let's say you're doing observations. You're watching things unfold. You're in a high school lunchroom. You're sitting there on the side. You're taking notes and you're listening to the couple tables around you. You could quantitatively mark down like a tally of how many times adolescents talked about their relationships. That would be a quantitative measure. You heard 24 instances or conversations of them talking about relationships during lunchtime. If you're watching a preschool classroom, you might count how many times did any individual child share. So Nico shared 5 times, something like that. How long did it take before someone interrupted the teacher? That's something that you might do as well. Your timing. So the lecture starts or the discussion starts in the preschool classroom, and just time how many seconds it is until a student interrupts. Versus qualitative, oftentimes you are getting this broad quality of data by recording and transcribing everything. So an interview, for example, you're getting a lot of information from a person, writing down everything they say, recording everything they say. And with this, you're probably looking for themes, repeated topics. So interviewing someone about their job. This is one thing I've suggested you do in the field, is talk to people about their job. So look for themes, like what were some of the things that they found most important? Like as you ask them all these questions, what are some of the key things that they keep coming back to, repeated topics? What themes are they trying to get across throughout the course of the interview? And it might not be in just one answer. It might be across multiple answers. It might not even be a question you ask specifically that brings out a theme. So finding all the statements about adolescent purpose in life and putting them in that category. That's one way that we still do, that we often measure adolescent purpose and see what exactly their purpose is. We just talk to them about their life. What are the things that they do? What things do they like to do? What things do they feel driven to do? What things do they do with family or at school or with friends? Like a whole variety of things. And if an adolescent does have purpose in life, that purposeful thing will appear in many different places. So we find all those statements and we are able to pinpoint, oh, this adolescent has this as their purpose. So that is quantitative versus qualitative. Oftentimes researchers use both. Most of my studies have used both quantitative and qualitative data. I've definitely done studies that focus more on the qualitative. For example, the interview study with heroes, almost entirely qualitative, but we're also getting quantitative data from it. So this percent of the population said these kinds of things, right? So, and then I've done other studies that are almost entirely quantitative, just doing survey numbers, giving rankings of things, but having some open-ended responses, and that gives me a lot of good information. So using both is often very, very useful. So let's talk about descriptive research. We've mentioned this before, but descriptive research describes a phenomenon. It's not trying to prove any kind of causation. You are describing the kinds of things you see happening. So you might observe a child playing with blocks or Legos and then describe how it looks like they went through that process. You might look at students interacting with peers or students interacting with teachers and describe what you think is happening here. So observational studies often are used for descriptive research. Surveys, you can do surveys to describe what's happening between variables. Interviews, asking people directly, hey, how do you think this works? What is this happening in your life? The purpose example I just gave. All of these could be examples of descriptive research. So case studies and content analysis, and we'll get more definitions of case studies and content analysis in a minute, but they're good examples of descriptive research. So one kind of observation that we want to talk about is naturalistic observation. You might also hear this called like field work or field observation. You're trying your best to observe in a natural environment or as natural as you possibly can. So this is an example of a picture watching gorillas. You're actually in nature. You probably don't actually want to be that close to them so that they have more of a natural interaction. They could obviously smell you from there, possibly interact with you. So this specific picture is not the best example of naturalistic observation. But let's say you wanted to watch undergraduates. You wanted to observe how they behave in a setting outside of school. So maybe you go to the Starbucks near campus. Undergraduate students are coming in, they're talking, maybe they're working, and it's a place you can be, and you can just observe in a college student's natural environment. You might also observe how a business or a school runs. So prisons, there's many places you can do a naturalistic observation where you're trying not to interact with the environment, you're just observing what's happening in as natural a state as possible. For a good example of this, a natural observation of school would be something that someone who's in the school could do. But let's say the principal comes into a classroom one day to observe. Is that now a naturalistic observation? Probably not, right? The presence of the principal there is probably not a usual thing. Maybe the class often has maybe classroom aides that change often, so a new aide who's actually observing the classroom might not change the behavior at all, right? So naturalistic observation, you're trying your best to have the environment as natural as possible. So another example of this, and not doing it the best way of getting actual naturalistic observations, is Margaret Mead, who did some research living with people in Samoa to compare the differences in the cultures and the development of adolescent girls. So with this, again, example, clearly a different person, clearly a person that's not been in the community before, coming in, taking notes, asking questions, doing interviews. So while it's attempting to get at completely naturalistic observation, and after a while, maybe you would get naturalistic observation. But immediately, behaviors would probably be different. And that's one thing that they found in reviewing notes and reviewing and re-reviewing people that Margaret Mead interviewed, is that some of the people changed their behavior intentionally to change results that Margaret Mead discussed in their work. So with this, usually with field observation, you're trying to paint a really complete, accurate picture of what the people and the context are trying to do. So you're not really testing a hypothesis here. You're just describing a lot of things. You're analyzing them, trying to find themes, then interpreting them. So these are the most common themes. These are the most important things to the people in this group. With this, qualitative methods are primarily used for these kinds of naturalistic observations. So another example is participant observation, a researcher who actually becomes a participant in a group, but the group in this case is not aware that they're a researcher. So let's say, for example, you join an AA group, Alcoholics Anonymous group. You are literally participating, but you're actually doing observation. In this case, it's close to naturalistic observation. You're participating, but you can get additional information that you might not be able to get if you just had, say, a camera in the room. You can get information about how friendships and relationships form firsthand. Probably is going to be a little less reactive to participants. But some negatives of this, you being a participant in the state, it might color your lens and your interpretation of what's happening. You might not be as objective. It could also create ethical issues too, with the kinds of treatments, what are you giving to people, what are they giving to you. It could possibly create ethical problems too. So non-concealed observation goes back to the example of the principal coming into the classroom. They're non-concealed, kids know who the principal is, they know the principal's sitting in the back of the class, and so this kind of example, non-concealed observation, is when participants know the researcher is there. So you use this for classroom observations. The problem here is while you're trying to get a natural observation, you might be changing the behaviors. If you've noticed this in the past, you might have had, say, a principal come and observe a class. Sometimes, I think it's like once a year, we get observed, all the faculty get observed by another member of the faculty. And so every time that happens, I tend to just forget some part of my lesson. So my behavior changes during the observation. So with this, you can't do much hypothesis testing with observational studies. It also does take a long time. It can be very expensive. The data collection instruments might be expensive, like literally buying cameras, buying computer analysis software, interpreting. So many variables to try and make sense of. So there might be it might appear that there's a clear relationship between three things that are happening there. But maybe there's a fourth thing also that might be affecting it in a way that you can't quite tell without doing some maybe more quantitative studies. But that doesn't mean that naturalistic observations are useless. They are very, very useful to get this good descriptive sense of what is happening here. What are we observing? So systematic observations take some of the positives of natural, and but they also bring in some of the negative. They take away some of those negatives because you're observing some specific behaviors here. Here you're looking for something specific. So in the observation example before, I talked about maybe you're looking for sharing behaviors. Maybe you're not looking for all behaviors of preschool students. Maybe you're only looking for sharing behaviors. That's a lot easier to maybe pinpoint and look what happens right before and then right after the sharing behavior. For example, oftentimes you're using coding systems for these observations. So a really good example of this is the strange situation. If you've taken the development class, you've probably also talked about attachment and the strange situation in a general psych class. But this is a really good example of a systematic observation. So in this kind of case, the parent comes in with the child, usually it's the mother. The stranger comes into the room, the parent leaves, and then you see the interaction between both the stranger when they come in, when the parent's there. You see the interaction with the stranger and the child when the parent's not there. You see how the child reacts when the parent comes back. So there's a lot of specific things that you're looking for. How does the child respond to the parent when they're with the parent? How does the child respond to the parent and the stranger when the stranger comes in? How does the child respond when the parent leaves? How do they respond to the stranger when they're there a few minutes? How does the child respond when the parent comes back? And from this systematic example, you can see a lot about attachments. You can look for attachment styles. Is this child securely attached, insecurely attached? And we'll actually watch a couple of video examples of just brief clips from the strange situation, because usually it takes like a whole 15 to 45 minutes to go through the whole strange situation, and we'll watch a couple like 3-minute clips. So with this, we're looking specifically for parenting styles. We might look specifically for like specific behaviors, discipline behaviors in say a home observation, but it's some systematic thing you're looking for. You're not trying to describe everything. You're looking for some systematic, some specific things. And you'll be using a coding system. So a coding system is really just a specific process or method to analyze those behaviors. So one thing that you might need for systematic observations is recording equipment, video, audio. This also helps with inter-rater reliability. You have other raters watch what happened or listen to what happened, and they can say, yes, I saw that specific behavior 5 times. If this person says I saw it 6 times, then you've got to figure out why are you disagreeing there. Reactivity. In something like a strange situation, you can create reactivity. You can have the participant change their behavior. Because yes, you might have a case where, say, a parent has a friend come over, then the parent has to like leave the room and go to the bathroom or something like that, and the parent comes back. So that could happen. But you're setting up this situation in a lab at a school probably. You're changing the environment. The person might know that they're being observed, so they might be reactive to that. Then also reliability. When you have 2 researchers coding the same kind of interactions, you want them to agree at least 80% of the time. Hopefully more, minimum of 80% to say that you have good data though. So let's look at the strange situation. So you're going through a series of interactions. The parent comes in with a child, a stranger comes in, the parent leaves, the stranger and the child interact, the stranger leaves, the parent comes back, or some variation of this. So we'll watch a couple of these interactions in a couple quick videos and see what you think. See which of these 2 examples seem to be a securely attached child and which ones seem to be an insecurely attached child, even though we haven't actually talked much about secure attachment. So a few things for your coding system. Secure attachments. A child usually uses a caregiver as a secure base. Maybe they'll come to them, show them a toy, run away and play, they'll explore. They might cry when the parent leaves, but they will be able to establish a positive connection with that caregiver when they come back. So after the caregiver comes back, they'll usually be able to get back to playing, versus in something like insecure attachment, you might see from the beginning they're kind of avoiding the caregiver. They don't have too much interaction with the caregiver. They may or may not be distressed when the caregiver leaves. And then when the caregiver comes back, they usually don't try to establish contact. So they might even move away or look away. So this is indicative of kind of the relationships you might see at home. Maybe the parent isn't there because they have to be at work all the time, right? So maybe the child isn't securely attached because they know they cannot rely on that caregiver for their immediate needs, right? Versus in the secure attachment, probably a little more responsive parenting. Maybe the parent is there all the time. And again, some of these things might be faults of parents, might not be any faults of the parents, right? So if you have to be working to be able to support, to have a home, that might lead to not being able to be there for immediate needs for a child all the time, right? So insecure resistant, this isn't a developmental class, so we will actually skip that one. And then there's also insecure disorganized, but they're all categories of insecure. So let's look at these two different examples. See which one of these is one secure, is one insecure. So put it down in your notes as we watch the first one and then as we watch the second one.
The caregiver then leaves and the stranger interacts with the baby.
So to be clear, since this clip is much shorter than the whole situation, the parent just left. So the stranger has already come into the room and the parent has just left the room.
Mommy will be back. Let's play together. It's okay. Mommy will be back. Oh, I know. Mommy will be back. It's okay. It's okay. Shall we play with the toys? Shall we play with the toys? Huh? Do you want to sit on here? Yeah? Yeah? Okay. Come on. Put 1 foot up. 1 foot up. And up you go. Now you're on a truck. Now you're on a truck. And you can push. Can you push? You want him to ride with you? I know. She'll be back. Oh, Mommy will be back. Mommy's coming now. Okay. Mommy's coming back. Mommy's going to come back.
The caregiver signals her return and enters. Reunites with the baby and interacts with the baby while the stranger
Are you
leaves.
making a sign for Mama's milk? Yeah. Yeah, it's not time for that right now. But we can play with some toys. Let's play with some toys. Do you see a big dinosaur? And do you see a tiger? Let's see if we can find the tiger. I think we can find him. Hi.
So a little time jump there. All right, so with that, we saw the first example. So what do you think? Going back to our coding scheme, does it look like they're using a caregiver as a secure base? Did they get back to playing? Did they cry when the parent leaves? Were they able to reestablish positive contact with the caregiver? Or were they showing insecurities? I'll go away. Were they showing insecurities by avoiding caregiver? Did they have little actions with the caregiver? Were they not distressed when the caregiver leaves? Did they establish contact? And then some of these, you might also see clinging to the caregiver as insecure, but not exploring the room, playing with toys. You might be hard to soothe when the caregiver comes back if you're insecure resistant. So this might be if a child needs that care from a caregiver, but they know they can't always rely on that. Maybe it's really intermittent, the kind of supportive nature of the care. So let's look at this other example, see if it's different, see if you can point out, are one of these secure or one of these insecure? You don't need to necessarily delineate between the kinds of insecure right now. In a developmental class, we would go over those definitions in more detail, but for our purposes, we're just looking at this systematic observation. So we're looking at this specific situation, and we're looking for these specific kinds of behaviors.
The baby? Hey, want to the baby? What's the baby name? You want to take care of it? Like this to me? Good. Like this to me? That's me. That's me. That's me. You fine?
All right, so those two examples, we did see different parts of the situation. Like this one, the first one, we saw a little more lengthy time right after the parent left, versus this we saw better, like little chunks throughout the situation. But it does give you some ideas of how the interaction is between that child and their parent, right? So which of those examples do you think show that the child was securely attached to the parent? Which of those examples do you think show that the child was insecurely attached? So with this, again, we just barely talked about these, so you may never have heard of secure attachment in a lot of detail or insecure attachment. But looking at these coding systems, so I'm flipping between secure attachment, insecure avoidant, insecure resistant. So which of those does look like it was the first case or the second case? So maybe write down in your notes really quickly. But that's what you're doing with a systematic observation, is looking for specific kinds of behaviors, even setting up a specific kinds of situation so that you can watch for something specific like that. So you are coding systematically to see, is there secure attachment, insecure attachment? The first example was definitely an example of secure attachment. The child was trying to seek comfort. You even saw the child asking for mama's milk. The second example, when the parent comes back, the child was kind of avoiding eye contact, not communicating with the parent, still watching the door for the stranger that just left. So definitely insecure attachment there. So these are the kinds of things that you would be looking for in specifically a strange situation, but also it's a really great example of a kind of systematic observation. All right, so let's go ahead past observations to case studies. So I've mentioned them a couple times. A case study is a really super in-depth observation of a single individual or a single case. So what a case means, a case is something unique, some bounded system around some unique feature of the case. So one easy way to think about this, we often think about like a case study in medicine, is someone with a really unique disease, like brand new disease, we've never seen it in the past, so we have one specific case. This unique feature is that disease. Another example of a case could be a specific school that started a new kind of reading program. That whole school that's doing it might be an example of a case because they all share that unique feature of all doing this new kind of reading program. So a case, we often think of it as one individual, but it can be a group. So here's another example. Maybe you are testing this child because they have a super high IQ. So you look at the case of that individual child, you look at their specific neurology, you do some brain scans, you ask them lots of questions, you ask their parents how they grew up, those kinds of things. So that is a really good example of a single person case. The feature that you're looking at is their intelligence. Why is that a thing? This is another interesting case where it's actually a group of kids. So this was a group of kids who created their own club. They created their own like science learning club without any intervention from parents, from any like teachers. They just all were hanging out and they decided, hey, we want to learn about this. And they're like, oh, I like that. And so they started forming on their own without support from outside people. These children, like pretty young, like from 6 all the way to middle teens, started forming their own organization and organized structure of a club to learn about something. So they literally built this clubhouse themselves as well. So it's a really great example of a case of a group of, I like this example because one, as a developmental psychologist, oftentimes we see that people don't value the contributions that children and adolescents can bring to a community, but they're often a lot more capable of doing things than we might give them credit for. And so this was a really good example of a case to look at, well, how did they organize? How did this come about? How do they structure their group now? How do they choose what to do for the next week, for their next meeting, things like this. So it's a really good example of a bounded system, but it's not just one individual, it is a group. So it's really in-depth system. But a neighborhood could be an example of a case, a classroom, a family, possibly even a school district could be a case. So it's around some unique feature. So here's a good example you've probably seen before. Phineas Gage was a good case study of what happens when your frontal lobe has a lot of damage to it. This was a railroad tie that exploded early and went up through his skull. So lost a big portion of his prefrontal cortex. People said his personality was very different. So studying that unique feature, that unique case, was a really good example. This is a group, I believe they're in Milwaukee, of black veterans of wars that meet together as a support system. They organize their meetings themselves. There wasn't like any other kind of community intervention. They just were like, hey, we want to do this. We want to do this for members of our community. And so they created their own group of support for black veterans in that community. So a really good example of beyond one individual, but they're sharing some unique feature, right? And so it's a good example of a case. So oftentimes we'll do case studies for people with unique memories, unique disabilities, diseases, or experiences, and it can teach us a lot. So if you went and asked this group of veterans about their experiences, you might find some really unique and interesting things about that specific group, right? And so that could be really useful for understanding and describing the experiences that Black veterans face. Another interesting example is people that it's not as common now because the easier to access this part of the country. So Troublesome Creek had a family where some of the children were born with blue skin, like pretty actually blue. I've looked a few times. I haven't been able to find any actual color photographs just because of the time period it was, but they had a blue tinted skin. And so that was an example of a unique feature that was present in a bunch of family members, but not every family member had it. So the unique feature that we're studying here is having blue skin. So case studies can be very useful. They can help us learn about exemplars of things. They can, on their own, they can't be used to prove or disprove ideas, but they might suggest some support or not support of theories of, say, learning. So if a child just wakes up one day and knows how to play piano, that might suggest that learning can happen in different ways than we previously thought, for example. They're often, but not always, used in some of the initial stages of investigating a phenomenon, so just the initial data gathering states. So understanding what this disease is about before getting in and really pinpointing things. Case studies and a lot of qualitative studies are often used as a first step, and then doing more quantitative studies or doing experiments later on, but not always. They can be the end point as well. So Jean Piaget's case studies on child thinking, for example, didn't prove anything, but gave a lot of helpful observations for original developmental psychologists to start to investigate. So it was a good broad description of, it looks like children are capable of these kind of cognitive capacities. Then more in-depth studies, some of them still observational or case studies or qualitative, were useful. So Freud had some good hypotheses and demonstrated some case studies, but never tested any of them in specific ways to show that they were valid. So later researchers took those observations, those descriptions, and built on it. So that's one way case studies can be used too. So another aspect of qualitative research is called archival research. This is data that's already been collected. So it's an archive of data. So there's a lot of different examples that this kind of data could be. Statistical records like censuses, survey archives. So if I collect my data and then I allow that to be publicly accessed later on, if you used it, it would be archival research because you're not collecting the data, you're just using the archive of survey data. Old videos, documentaries, news reports, lots of studies in, say, anthropology, history, things like that use old documentaries, old videos, old news reports to see what is going on at this time in history. You could also use the research notes from an anthropologist. So that's one thing people have done with Margaret Mead's studies, is look at the old research notes that Margaret Mead had made compared to what we understand about development now. Another good example of this is look at the notes that Phil Zimbardo made and some of the documentation of the Stanford prison study. So researchers now have gone back and looked at some of those things and been able to understand a little more or learn more from that or explain what was going on there. So another good example of archival research is personal journals or maybe letters. So if you're writing in a journal right now, someone might use that as archival data in the future to understand what the perceptions were or things that were happening now at this time. So you can do a content analysis, measure how often do you see certain words, what are themes that are coming up again and again. So that gives you a couple really good examples of types of qualitative data. Again, most researchers do tend to use both together. Some studies might be more fully qualitative or more fully quantitative, but a lot of times it's very useful to use both so that you're hopefully not missing things. So again, descriptive research is usually what we're doing with qualitative data. So it's describing what's happening. It's not trying to prove causation, but it can be really, really useful. So in our chapter on correlation and causation, we'll talk mostly about quantitative studies that will help to do the actual quantitative testing and proving causation, or at least showing more clear relationships statistically.